In this video, we will do page number 25, and we will do flowchart and paragraph proof. And we will compare it to two-column proofs. So let's see, example 1. Example 1. Use the given flowchart proof to write two-column proof. So given information and prove this statement. So in the flowchart proof, where do I begin? Usually I have one place to start, but this one I have one from here, the other from here. They merge here, and we have one conclusion at last, right? So that is the format of a flowchart proof. And let's see, two-column proof. Anyway, where do we begin to prove? Always start with given information. Do you see given information here? Yep, so I need to keep those together, okay? Is this here? Yes, it is. Is this here? Yes, it is. So nothing to do for the first part. Now let's do number 2. Second step. It says use definition of complementary angles. So which one is using complementary angles? Complementary angles here, right? So this is from above. Angle 2 and angle 3 are complementary. By using the definition of complementary angles, we can say measure of the angle 2 and measure of the angle 3 are together makes 90 degrees. So this is going to the next step, flow chart, right? So this is from first given, okay, first given. Make sense? Now let's look at the third step. Third step says use definition of congruent angles. So I need to go to the next step. Next step right here. Measure of the angle 1 and measure of the angle 3 are same. So this is the given statement, second one, and I need to take the same one here. So this is notation about geometry. So I'm going to say the number from it. The measure of the angle 1 is equal to measure of the angle 3. So what is the logic between geometry word and algebra word? I must use the definition, right? So logic will be definition of what? Congruence, right? Congruent. Are we talking about segment or angle? Angles. So we write definition of congruent angles. Two angles are congruent, measures are same. That's how we write it, okay? So we got that part. And next step, number 4, okay, we have this. And what does it say under the statement? That is the logic. So we have measure of angle 2 and measure of the angle 1, same as 90 degrees. How do I get that? So look at the pattern. Oh, it'll just look like this equation, but it's different, right? Which part is different? It's exactly same except that part, right? What did we do for that part? I replace it. That's right. So we have to use substitution, property of equality. Okay, that's the reason. Am I done? No, one more? Yes, one more. How did you know? Yeah, we have to finish the sentence with a thing to prove. What is the proof statement? Angle 2 and angle 1 are complementary. Complementary. Okay. Why? That's right. From number 4 to number 5, what's the logic we are using? Definition. Definition of what? Complementary angles. That's right. That's the angle notation. Angle, okay? Complementary angle. Or some people or some book draw angle a little bit longer like that. That's the notation. Or you don't like it, and then you can write it. Angle. Complementary angles, complementary angle, complementary angle. Okay. Any questions? All right, let's see number 2. I want you to think about it first, and then let's check together, okay? At First of all, let's change the notations. The thing to prove is with the congruence, and then we need a geometric notation. So that's typo. Okay, so fix that part and then do it. I fixed it for next year on the original copy, but not here. So add segment notation above the name of the segment and try, and then let's check together. Okay, now let's check answers together. Where do we begin? Here and here, right? So let's see. What is the given information? From this part, given is RS equals to UV and ST equals to TU. Okay? All right, that's given information. Where do we finish this proof? Proof statement, the last one, number 5, RT segment is congruent to segment TV. So that is the thing we need to finish it, right? All right, now let's look at the flowchart proof. Okay, from the given, they use addition property of equality, and they have this equation. Do you see this equation is with a different color on my paper? Yeah, so what does that mean? Left hand side together. That's the meaning. The other side, right hand side together. So we add it. Okay, so this is addition property of equality. So think about what we did in system of equations in algebra 1. You have two equations, and we can add left hand side together, right hand side together, right? That's the addition property of equality. So we created this one, okay? Next step, what do I need to start with? Here's a hint, right? I need to use that part. So let's use that part, number 3. So RS plus ST equals to RT. What does that mean? And I'll show you in drawing, okay? Here's R, here's S, here's T. I have 3 points in one segment. So they are collinear, okay? Co means sharing. Linear means line. So let's say I have point R, S, T. Can I say segment RS and segment ST together? Can I name it as RT? Yes, it is, right? So what is the name of the postulate? What did we add? Segment, right? So that is called segment addition postulate. Okay, like this. And let me go with the other segment, which I'm going to use. Let's say T is here, U is here, V is here. Can I say TU and UV all together as TV? Yep, that's right. What is the name of the postulate? Segment addition postulate. So that was the key, right? So we are using this from the diagram. Add two little parts, it form a big one, right? Addition postulate on the segments. And then we can conclude this statement. RT is the same as TV. How did we get that? RT is same as TV. These left-hand sides are same, right? And then it is given same above, right? So by using the substitution property of equality, we can conclude number 4. And then we can say two segments are congruent. Make sense? Why two segments are congruent? That's right. We are coming from algebra world to geometry, right? So we must use the definition. Definition of what? What are we talking about? Congruent segment. Okay, so definition of congruent segment was used. So this is a guided one, so it's like training wheel for the bike, okay? It will be removed, and we need to know how to prove from these two statements. That's the goal of practicing this. Next page. We're doing backwards. Okay, it could be a little bit easier then, right? The left column, we have statements. Right column, we have reasonings. Can you rewrite this on the flowchart proof? Okay, let's try and then let's check answers together. Okay, let's do number 3 together. Number 3. B is the midpoint of the segment AC. So let's put point, okay? The drawing is not completed. Okay, here are the points. If B is the midpoint, by the definition of the midpoint, we know that these are cut through, right? And the length is going to be equal to each other. We are going to prove twice of the small segment length is same as the longer one. That's obvious, right? We'll show logical thinking one at a time. So let's look through two column proof and then let's fill in the blanks on flowchart proof. So B is the segment, P is the midpoint of the segment AC that is given by definition of the midpoint, and we can say these two are congruent to each other. Using the definition of the congruent segments, we can say two measures are same. So we can use segment addition postulate from whole length divided by two parts. So we can say that equation, and we will use substitution. We will get these two are congruent to each other. So here, I want you to see AB, AC, same, right? Nothing changes. And here it is changed. What happened? Because of number 3, we can say the number 5, right? All together above create the number 5 statement. Make sense? What happens? Substitution. We use the different quantity and then equate it together. And left-hand side, we simplify AB together. That's 2, twice of the segment. And then we can finish it. So let's start with the given statement. What is given statement? B is the midpoint of AC. Segment AC, period. Here, typo again, right? Segment of AC. All right. I need to change that part again. All right. And then two segments are congruent. Why? Did you write any reasoning below that statement? And we need to write it, okay? You don't see blank, but you need to write the reasoning because of the definition of midpoint. Midpoint, that's how we write short, okay? Definition of a midpoint, we can say two segments are congruent. After that, we can say AB length is same as BC by using definition of congruent segments. So be careful with the notations. We are talking about geometry here. We are talking about algebra here. And another story starts. Look at the long segments. You can think about sum of two parts. So these two parts together makes that, and that is addition, segment addition postulate. And using these two together, we can have the fifth one, right? So we will write down fifth one, AB, and AB equals to AC by using substitution method, okay? Instead of BC, we plug AB. That's what happened here. And left-hand side, we are simplifying. Simplify, so AB together to AB. So we finish the statement. So this is the proof of example number 3. Any questions? Right, last one. Example number 4. Use the given two-column proof to write a flowchart proof. So angle 2 is congruent to angle 4. Okay, and measure of the angle 1 is wrong notation. I need to change it. This one must be equal sign. If we say measure of the angle 1, measure of the angle 3, that means algebra number on it, okay? So we must use equation. So always make sure you are using the right notation, okay? I'll fix that for next year. Okay, equal sign there. So we are starting with given statement. Two angles are given. And number two statement, angle 1 and angle 2 are supplementary. Also angle 3 and angle 4 are supplementary from this diagram. And we can conclude that measure of the angle 1 is same as measure of the angle 3. Why? What kind of angles do we see? So we are going to follow that directions, okay? So starting with given information, and we use the linear pairs. It says theorem, but the linear pairs is actually postulate. Linear pair postulate. Let it go, okay? Linear pair postulate, and we can say they are linear pairs, so they are supplementary angles. And then next step, we can say supplementary congruence theorem. So these two are congruent, and each of 1 and 3 are supplementary to the congruent angles. So we can conclude the first and the last is same by using congruent supplementary theorem. So we can go to algebra. Measure of the angle 1 is same as measure of the angle 3. That's obvious, right? Because if two lines are parallel, we see this kind of angle relation from parallel lines, right? So we will figure it out. Where do I begin? Which is given? So let's start with angle 2 is congruent to angle 4. That is given. So given from left to right this time. Okay. And let's start with another linear pair theorem. That bothers me. Linear pair postulate. Angle 1 and angle 2 are supplementary. Angle 3 and angle 4 are supplementary. Okay. And all together we get there, and then we can conclude the measure of the angle 1 is equal to measure of the angle 3. Why? By definition of congruent angles. That's right. And what is missing here? The reason here, right? That's congruent supplements supplementary angles theorem. Okay. All right, that's it. So it requires lots of practice. Read and try again, and try to do it on your own, okay? Not reading this. So you can do it on your own. That is the goal of this practice.